Today we are continuing our topic scalar and vector quantity. And I remember last class we talked about what are scalar quantities and what are vector quantities. We say scalar quantity are quantity that has only magnitude. In other words, they are only expressed in terms of a value. But vector quantities are quantities that has both magnitude and direction. In other words, those ones are expressed only in terms of value and they also have direction. And I remember last class we were able to look at examples of scalar quantities and the examples of vector quantities. And from there we talk about the manipulation of vector quantities because we realize that vector can be represented both in magnitude and in direction. So we look at the manipulation of vector quantities. Now, under the manipulation of vector quantity, we're able to establish the fact that in this manipulation, we'll talk about what we call a resultant force. And we say this is a single force that can represent all other forces in a system and still produce the same effect, both in magnitude and in what? In direction. And from there, we look at the parallelogram law of vector, whereby we're able to establish that when we have two forces which are at a particular angle to each other and they represent the two adjacent sides of the parallelogram, we say that these two forces, their resultant is the line that is drawn from their common point, which is the diagonal. And we say that the magnitude of this resultant is the square root of f1 square plus f2 square plus 2f1 f2 cos theta. And from there, we look at the direction of this resultant force. We say the direction of the resultant force is the direction which the resultant force made with the horizontal. And from there, we now look at three special cases of this. We say that these three special cases of this parallelogram law of vector is number one, when these forces are parallel moving in the same direction, we say that the resultant vector is the forces, the addition of the two forces, F1 plus what? F2. And at this point, we say that the angle between the two vectors is what? Is 0 degree. Therefore, the resultant is maximum. I hope you can remember that. Then again, we talk about the two parallel forces moving in opposite direction. We say that the resultant is the subtraction of the what? The vector, which is what? F1 minus F2 or F2 minus what? F1. And we say that the angle between these two forces is equal to 180. And at this point, the resultant force is a minimum. And the last one, which is a special, which is one of the most important, is when they are perpendicular to each other. The angle between them is what? 90. Thank you. And from there, we say that the resultant is just the square root of f1 square plus f2 square. Now, that was where we stopped last week, and from there, we want to continue from there. Today, we're going to talk about resolution of vectors. Now, in resolution of vector, in this case, we are going to be seeing that several forces or several vectors are acting on a body. So we want to resolve those vectors into a single vertical component and into a single horizontal component such that this horizontal and this vertical component of these forces or this vector represent the two perpendicular sides of a triangle. In other words, remember the third case we did, we said that we have F1 and what? F2. So in this case, the resultant is this line that is drawn. And we said that the resultant is the square root of who? F1 square plus who? F2 square. But in this case now, we want to do that when several forces are acting on a system, we want to resolve it into one, a single vertical force, which is called F what? Y, summation or the Fy, and resolve it into a single horizontal force, and that is summation who? Fx. And at this point, the angle between the two vectors still remain what? 90. In this case, we still want to get the what? Resultant. So we want to, in resolution, we need a single vertical force, addition of all the forces into a single vertical component, and this addition of all the forces also into a single horizontal component. Then we can now come and use this particular formula. So under resolution of vector forces, several vectors are acting on a system, and the goal is to resolve it to a single vertical component and a single horizontal component. Now, one of the things I do tell students, and to make it much easier for us, is I title it in a simple way, in a way that if you look at it, it makes sense that there's nothing like that. But for more simplicity, let's look at that way with what exactly I said. Now, the first thing I want to establish is that there are three natures of forces. nature of forces. There's no word like that, but let's take it that way. There are three nature of forces so that you can understand this resolution perfectly. The first kind of force in nature is called a vertical force. A vertical force, by its nature, is that the force is vertically upward, or the arrow, the direction is up, or the force is vertically downward. So which makes sense. And what we are saying is that when we say a vertical force is a force that is either pointing upward or is pointing what? Downward. Now, from the word vertical force, that means as I'm looking at this force, the only effect that this force can produce is only on the vertical direction. No, this simply means that if this force has only effect on the vertical direction, that means the horizontal part of this force is of no effect. That means this guy has no horizontal component. Now, the second nature of force is called the horizontal force. In the case of the horizontal force, what we have is also a force in the horizontal direction of F1 and a force again in the horizontal direction of F2. This is horizontal forces. In the case of these horizontal forces, what you are seeing is that this is also horizontal. Either it's moving to the right or this force is moving to the left. Now, in this case, I call it horizontal. It means this guy only has effect, this guy only has effect only in the horizontal component or part. That means this guy has no vertical part at all. Now, the third one, which is very important, is called an oblique force. Oblique. What is this oblique force? It means that this guy is not vertical and this guy is not horizontal. This is what we call an oblique force. Now, one thing we need to establish to make this work very simple for ourselves is that when I say a vertical force, that means this force is vertical, has no horizontal component, it only has a vertical component. Now, if I say an horizontal force, that means this force is horizontal, has no vertical part, it only has horizontal what? Component. But when I'm dealing with an oblique force, this oblique force, the first thing that must be registered in your mind, that this guy has two components. This guy has both vertical components and what? Horizontal components. How do I know? This force, as you are seeing it, does not exist alone. This is an independent force. In other words, it exists alone. This is also an independent force. It exists alone. But in the case of this, is a dependent force. It does not exist alone. How do I know? If I draw a straight line this way, down, I draw another straight line this way, what do you see? These two lines meet at what? 90. Which tells us that this particular force is complete when I draw a vertical and what? Horizontal. The vertical part of this force is called Fy. The horizontal part of this force is called Fx. Now, note, it is important to understand the direction of this Fy and Fx that I'm introducing. Now, this oblique force, the first thing you need to know about oblique force is that it's a resultant of two perpendicular force. Your oblique force is a resultant of two perpendicular force. And remember in last class, I told you, anything that we call resultant means it is the only one that moves in opposite direction. Two perpendicular force means that vertical and horizontal that meet at where? 90 degrees. How is the oblique force going? This way. Automatically, these two forces must go in the same direction, but they must oppose the direction of the oblique force. Which means this must go this way and this must go this way. This and this are in the same direction, but this is in opposite direction, which shows that truly this guy is a resultant of these two perpendicular forces. The first I gave you is F. But I find out that this F has two components, a vertical component and what? An horizontal component. Now, for simplicity of the class, don't stress yourself. Now, in this case, this oblique force has ability to form angle with two. Is that it form angle with the vertical force or it form angle with the horizontal component? Either with the vertical component or horizontal component. But for the simplicity of this class, don't stress yourself. The only angle you are interested with is angle that is between the oblique force and the horizontal. And that angle is this angle called theta. Now, in this case, that tells you that the side facing 90 degrees become your hypotenuse. That's the oblique force itself. The vertical component of this force now become the opposite, while the last one now become who? Adjacent. So what is very important for me is to resolving the force F into who? A vertical component and who? Horizontal component. So how do we go about that? This is exactly what we now need to do. Remember your Pythagoras theorem? What does Pythagoras theorem say? So that means that the vertical component, which is opposite over hypotenuse, is who? Sine. Sine theta is opposite over who? Hypotenuse. So that means your sine theta, what is opposite? Fy, hypotenuse, F. So what do? We cross multiply. So if we cross multiply this times this, so Fy times 1 will give you what? Fy. Sorry, and this times this will give you F sine theta. This, as you are seeing it, is the vertical component of the oblique force. Vertical what? Component. So the vertical part of this force, provided that this force make angle with the horizontal, is going to be that force multiplied by sine of the angle. Don't stress it. Once it is angled to the horizontal, the vertical component of this force is the force multiplied by sine on the angle. What about the horizontal component? In the case of the horizontal component, what do we have in the horizontal component? This is adjacent, is what we're looking for, over hypotenuse, that's your word, cos. So cos theta is adjacent divided by who? Hypotenuse. So which means that cos theta, adjacent. What's adjacent here? Fx. What is hypotenuse? Hypotenuse is who? F. So cross multiply, what do you have? This is going to be Fx is equals to F cos theta. And this gives us the horizontal component. Now, quick one. What is important for us to note is that if this is our horizontal component, now, by analysis now, let's quickly analyze what we have. Remember we said we have three nature of force. What are the three nature of force? We have the vertical force, horizontal force, and the oblique force. In the case of the vertical force, that means that a vertical force is a vertical. That means it has no horizontal. And horizontal force is an horizontal force. That means it has no vertical. But however, in the case of oblique has the two components. It has both the vertical and the horizontal. What is important for us is to get we want to know about this oblique force. We draw a straight line vertically, straight line horizontally. Both of them meet at what? 90 degrees. The vertical part of this oblique force, provided, don't stress it, what you're looking for is the angle made with the horizontal force. Yes. If it is made with this horizontal part, then the vertical component of this guy is this guy, which is this oblique force, multiplied by sine of the angle. While the horizontal component of this oblique force, it is this same oblique force multiplied by what? Cos of the angle. Now, if you are able to establish all these facts, then our work becomes easy under what? Resolution of vector. Now, under the resolution of vector, what do we now need to do? The essence of resolution of vector is that when several forces are acting on the system, what I now want to do is to get a single vertical force, which I will call summation of Fy, and a single horizontal force, which I will call summation of Fx. And on getting this, what will happen is that I will now get my resultant, which is your what? My R. By using this parallel to this, then this also your summation Fy. What do you observe? This and this are in the same direction. This resultant is in the opposite direction. So what do we do about this? To get the magnitude of the resultant, it will now become the square root of what? Summation of Fx squared plus the summation of Fy all squared. So this is this formula to get the magnitude of the resultant. Magnitude. Now, the next thing we now need to do, once we have gotten the magnitude, what are we looking for? The direction. And I've told you, the direction of every resultant is the angle with which the resultant make with the horizontal. So this become opposite, this become adjacent. So what do we say? To get direction, we now say that what? Tan alpha is opposite over adjacent. So from here, our tan alpha, what is opposite? Summation of Fy What is adjacent? Summation of who? Fx. And from here, to now get the direction that we are looking for, our direction, which is who? Alpha, will now be what? Arctan of sum of all the vertical components over sum of all the horizontal components. This formula is the formula for the who? Direction of the resultant what? Force or vector. Then, after we have established this, now, before we even come to any of these, remember we said that it's resolution. When I'm resolving the force to a single vertical and a single horizontal, I need to understand the individual forces I am operating with. Those individual forces, they have what we call signs in what I'm doing, which we call the sign convention. Sign convention. What is the sign convention? So the sign convention is very simple. What are we saying? If I am dealing with the vertical part of the force, the vertical component of the force, the rule is this. Remember your graph, this is positive y. Your graph, this is what? Negative y. If it is vertical, any force that is pointing upward, please note that word, pointing what? Upward. The vertical component of that force is positive. But any force that is pointing downward, it is what? Negative. Please don't forget that word. Point up and point. Once the arrow of the force is pointing up, the vertical component of that force is positive. But once the arrow is pointing down, the vertical component of that force is who? Negative. Whether the vertical force is vertical in nature or the force is oblique in nature, once the pointing of the arrow of the force is up, must be positive. If it is down, it will be what? Negative. In the case of horizontal component, what happened horizontal component? This is it. Your graph too. Remember, this is positive x and this is negative x. Once your arrow is pointing what? To the right, then that guy will be positive, the horizontal part. But if it is towards the left, it's going to be negative. So it's very simple. When I'm looking at a force, once I understand what kind of force is, the next thing is to know what sign will follow. If it is vertical, I'm considering pointing up of the force is what? Positive. Pointing down is negative. For horizontal force, pointing towards the right is what? Positive. But pointing towards the left is negative. Are we clear? So these are just the summary of what we are going to do under the topic called the resolution of a vector of forces. So the next one now we're going to look at an example to show exactly how do we resolve forces. Just on the concluded resolution of forces, and this is one of the questions you will see in your Utme past question. It is JAM 2007 question 42. Now you can see the diagram here. These are several forces acting on particle P. We'll read the question just to give you an overview of what the question says before I read it. So what are the forces? You have one acting on it, 3 Newton, 10 Newton, 3 Newton, and 6 Newton. So let's look at what the question says. The question says the figure above show 4 forces. What are the 4 forces? 3 Newton, 10 Newton, 3 Newton, and 6 Newton acting on particle P, as you can see. Now, the resultant of the 4 forces is option A, 10√3 Newton, option B, 10 Newton, option C, 5√3 Newton, sorry about that, and option D, you have 5 Newton. Now, one thing I've told you under resolution, which you need to know as a student, is please don't stress yourself. All the old things that we explained earlier, we want to make use of them and see how easy resolution of forces. No matter how, if there are 20 forces, it is the same pattern. So what do you do, my student? The first thing you do is to draw a simple chart, a table. Put here, this is for the force. Remember what we want to achieve is that to put all this force, number 1, in a vertical component. The second part is to put all the force in horizontal component. These are the 2 things. Now, don't forget the nature of your force. We have vertical, horizontal, and what? Oblique. And don't forget your signs also. If your vertical force, if the arrow is pointing up, positive, pointing down, negative. Don't forget for horizontal, if it's towards the right, positive, towards the left is negative. So let's make use of it then. Now, I'm going to be calling the first one after the other. We will identify them, then we'll look at what their values will be. So the first, let's go in this direction. So we are starting with what? 3 root 3. Sorry, 3 root 3, yeah. For 3 root 3 in Newton, what do we have for 3 root 3? This 3 root 3 Newton, the first question is, this guy, is he a vertical force, horizontal force, or oblique? As we can see, this guy is pointing upward and it's straight. It is a vertical force. What do I call it? Vertical. Once I know it is vertical, the first thing I must attend to is to go straight to the horizontal. The horizontal of this guy is equals to 0 because I've called it what? Vertical. So what will now be the vertical component? The vertical component of this guy is its value itself, the way it is. What is it? 3 root 3. Case close. Now the next thing to do is this one that have value. This one does not have value. So this one that have value, we need to look about the sign convention. Because we are dealing with vertical. This force, is it pointing up or is pointing down? Pointing up, correct. So this guy is going to be what? Positive. Perfect. And after that, I move to the next one here. What is the next one? 10. This 10, what kind of force is 10? Is it vertical, horizontal, or oblique? Without wasting time, this guy is what? Oblique. Now, for every oblique force, remember we said what we are looking for is angle to the horizontal. This is the horizontal we are talking about. What angle does this 10 make with the horizontal? 30. Don't stress it because it's an oblique force and it makes 30 degrees with the horizontal. What do? Just say horizontal is what? Vertical is sine. That will be 10 sine 30. And this is going to be what? 10 cos 30. Case closed. It is an oblique force. Angle is 30 degrees to horizontal. Straight away, vertical is the value, sine 30. Horizontal is that value, cos 30. Case closed. Now, the next thing we now need to talk about is the sine, because both of them have value. In terms of sine, what do we have? For vertical, what is our main aim? Pointing up. Is this guy pointing up or down? It's pointing up. Positive. Correct. For horizontal, what we talk about is it pointing right or is pointing left? So is it pointing right or left? Right. Positive. Confirm. And don't forget, in this case now, we have to solve these two values. Sine 30 is what? Half. So 10 multiplied by half will give us what? 5. Cos 30 is 10 times cos 30 is root 3 over 2. No, this is Jam, I don't use calculator, so you have to be either 2 here, 1, 2 here is what? 5. So what do you call this one? 5 root 3. So the value of this one is 5 root 3. The next one we are going, this is the first one. This is the second one. The next one we are going now is 3 Newton. 3 in Newton. This one is here. What kind of force is this 3? This 3 guy is what? Horizontal. What did I call it? Once I mention horizontal, my vertical is what? 0. No cause for alarm. But what will not be the horizontal? Horizontal is the value itself, 3. Then the next one is because the horizontal has value, we need to know the sign. What sign am I going to give to this? So in this case now, for this sign, is for horizontal. We say that right or what? Left. Where is arrow pointing? Right. Because it's pointing right, then this is going to be what? Positive. Clear? Good. Then the last one we are going to talk about, which is the last force, is 6. What kind of force is 6? 6 is also oblique. Why? It make an angle what with the horizontal? 60 degrees with the horizontal. Without wasting time, what do? Because it's angle already to the horizontal, it will be what? 6 sine 60. And this is going to be what? 6 cos 60. Don't stress it. If that is the case, the next thing to talk about is the sign. If we are to come to vertical, we won't talk about vertical now. This guy in the vertical direction, is the arrow pointing up or the arrow is pointing down? It's pointing, if it is down, what do we say? Negative. Now we are done with that. In the case of horizontal, what do we talk about? Is it pointing towards the right or is pointing towards the left? In this case, pointing towards so this one will also be negative. Now, what is sine 60? Sine 60 is also root 3 over 2. So this is going to be minus 6 times root 3 over 2. So what do you get here? 2 here, 1. 2 here is what? So that will be minus 3 root 3. So this is minus 3 root 3. So what is cos 60? Cos 60 is half minus 6 times 1 over 2 here, 1. 2 here is 3. What do you have here? Minus. So the answer to this one is minus 3. So from here now, the next thing we're going to do is to now do what we call, remember, we have resolved all this force into a single vertical component. We call it summation what? Fy. We have resolved all this into a single horizontal component. We call it summation who? Fx. So let's add them together. This is plus root 3. This is minus root 3. So plus root 3 cancelled minus root 3. So what are we left with? This will be 5 plus 0. What will be left here is who? 5. If we come here again, this is minus 3, this is plus 3. This cancel this. So what are we left with? Is 0 plus 5 root 3. What will we have? 5 root 3. So what is our formula to get the resultant? The resultant says is the square root of summation of fy squared plus summation of who? Fx squared. So my resultant is the square root. What is the fy? Fy is what? 5 squared. This is it. What is fx? Summation of what? 5 root 3 all squared. So my resultant equals to square root. What is 5 squared? 25. Plus, what is 5 root 3 all squared? This means 5 root 3 times 5 root 3. 5 times 5, 25. Root 3 times root 3, that is 3. 25 times 3, what would that give us? 75. This is going to be plus 75. So my resultant becomes 25 plus 75. What do you have? 100. So what would that be my resultant? What's square root of 100? 10 Newton. So if I resolve all these forces into a single component, the single components that the single resultant force is going to be 10. And from the option A, 10 root 3, 10, 5 root 3, and 5. What the answer? The answer is option B. That is 10 Newton. Is it clear? This is exactly how to solve question on resolution of forces.